Let's look at another example problem. A disk has a mass of 2 kilograms and a radius of 2 meters. It rotates with an angular speed of 3.5 radians per second. What net torque must be applied to bring it to rest in 3 seconds? All right, so first off, we're told in this problem that we have a disk, and we're given the dimensions of the disk and how much its mass is, so we should be able to calculate this disk's moment of inertia. So the moment of inertia of a solid disk is 1/2 times the mass of the disk times its radius squared. In this case, its mass, we're told, is 2 kilograms, and its radius is 0.2 meters. And so this disk is going to have a moment of inertia that's equal to 0.04 kilograms times meters squared. So that's its moment of inertia. We're given some other facts as well. We're told that it's starting out with an angular speed of 3.5 radians per second. So its initial angular speed is equal to 3.5 radians per second, and that it's brought to rest. So that means its final, so this is the initial, and its final is 0. And we're also told that we are bringing it to rest in 3 seconds. So the amount of time is 3 seconds. And what we want is the torque. We want to know what net torque has to be applied in order to bring the disk to rest. So we want to know what is torque. So torque, we know we can relate to angular motion because torque, the net torque, is equal to the moment of inertia, which we have calculated, times the angular acceleration. So I think using these rotational motion facts, I can find the angular acceleration, and once I find the angular acceleration, I can multiply it by the moment of inertia to get the torque. So the angular acceleration, this is my unknown, and here are all my knowns. So if I look back at the equations for constant angular acceleration, there's this one where the final angular velocity is equal to the initial angular velocity plus acceleration times time. And I know that the final angular velocity is 0. So this is 0. This is equal to 0. So if I bring this omega naught to the other side of the equation, I have minus the initial angular velocity is equal to alpha times time, and then I can just divide both sides by time. So my angular acceleration is equal to minus the initial angular velocity divided by time. And plugging in numbers, the initial angular velocity is 3.5 radians per second, and the amount of time is 3 seconds. So that means my angular acceleration is going to be equal to negative 1.17 radians per second squared. And the negative makes sense because this disk is slowing. It's slowing down. So then I can use this fact to calculate the torque. So the torque is going to be equal to the moment of inertia, which is 0.04 kilograms times meters squared, multiplied by the angular acceleration, which is negative 1.17 radians per second squared. And that's going to give me a torque of negative 0.0467, and the units for torque is newtons times meters. So I can see here I have a kilograms meters squared over second squared, and that is equivalent to newtons times meters. So the net torque that must be applied is 0.0467 newtons times meters, and the direction is given by the minus sign, and this minus sign indicates that the direction is going to be opposite the direction of the angular velocity. So I need to apply a torque in the opposite direction in order to slow the disk down and bring it to rest. So here is another question. A constant net torque is applied to an object. Which of the following will not be constant?